Welcome back. In this lecture, we will solve more problems on Thevenin's theorem. In the last lecture also, we have been determining the Thevenin's equivalent circuit for given networks, and we will continue the same in this lecture also. So I hope that you will be getting familiarized with determining the equivalent, Thevenin's equivalent of given networks. So a quick review, you know that any network is to be replaced with a Thevenin's voltage source in series with a resistance, which we call it as Thevenin's resistance. And the steps, the first one, remove the element. Second one, determine the VTH. Third one, replace all the sources. Fourth one, determine the RTH. And fifth one, draw the Thevenin's equivalent circuit. So now, this is the circuit which has been given for you. Using Thevenin's theorem, you are supposed to determine the current in this 6 ohms resistor. Okay, so we will be following the same 5 steps which we have been following in the last lectures also. So the very first step is to open circuit the terminals A and B by removing the 6 ohms resistor. Now I'll show you how this circuit will be. So this is the circuit. I have removed this 6 ohms resistor here. So whatever the voltage which is appearing across these terminals, I'll refer it as VTH. Okay. And the equivalent resistance I'll refer to as R equivalent or RTH. Now coming to step number 2. Now I will redraw the circuit. So this was my terminal A and this was my terminal B. So I'll take it as 0 volts. So this will become, this is 4.5, right? So this will become 4.5 and this is 3 volts. So this will become 3. This one I don't know. So I'll take it as VA. Okay. So now how many parts this effective node VA has? It has 2 parts. One is VA minus 4.5 by 4 ohms. The other one is VA minus 3 by 5 ohms. So I'm taking these 2 parts, I'm applying KCL here, okay, I'm employing nodal analysis and I'm applying KCL here. So if I solve this one, I'll get VA is equal to 3.833. So then what is the VTH then? VTH is equal to VA minus VB. VB I already have taken as 0, so now I have obtained VA as 3.833. So this is my voltage, 3.833. Then step number 3 is we should replace all these sources with internal resistances. Now I do have 2 sources. This is one source, this is the other source. I'll replace it with the internal resistances. So which means that it will be short circuited. Ideally, it will be short circuited. And so that's why this is my A terminal, this is my B terminal. I'm just shorting this one. Okay. And here also I'm shorting. So I do have now 2 paths here. 4 paths. This is, if I take here, this is the current entry, either it will be, so I do have 2 parallel paths now. One path is having 4 ohms resistor, the other one is having 5 ohms resistor. So it can be seen that both the resistances are in parallel with each other. So we consider it like this. It will be easier for you. Entering and this is leaving. So this is one path and this is another path. 2 parallel paths, 4 by 5, 4 into 5 by 4 plus 5. This is R1, R2 by R1 plus R2, equivalent resistance. So I'll get 2.triple. So now what is my VTH? I've already obtained as 3.833, RTH is 2.22. The final step is drawing the equivalent circuit. So I'm replacing this entire network with Thevenin's resistance and in series with Thevenin's voltage in series with Thevenin's resistance. Now I am replacing the resistor which I have removed earlier. So this is 6 ohms resistor which I have taken off in the earlier case. So if I replace this one, now if you want to determine the current, what is the current now? Current in the network? It is very simple. VTH is the only voltage which is present here. My total resistance is 2.22 plus 6. I'll get somewhere around 0.466 amperes. If you want to determine the voltage, it is I into R. It is 0.466 into R is 6. R is 6. You can determine the voltage. If you want to determine the power, then it is I square watts. So anything you can determine. Okay. So I hope that now you are able to determine the Thevenin's equivalent. I am giving you one more problem for home. So try to solve this problem at home and come back to home. You need to determine the power loss in 1 ohm resistor. You know how to determine the power loss? It is I square R. Or you can take V into R. Anything is okay. So in the 1 ohm resistor, so you take these terminals as A and B. First of all, you remove this resistor, determine VTH, next replace all sources, and next determine RTH, and finally again replace the entire. Okay, so I hope that you will be doing these problems at home and come back to the class so that we will discuss more on Thevenin's theorem. That's it from my side. Thank you.